Dear student, welcome to this chapter 4 of your GAS course. Today we will discuss part of the handling system, of the cargo handling system on board of a liquefied gas carrier. It means that we will make a virtual round on board of a vessel and we will discuss each item that we meet and that is cargo related, so that in the end we have seen everything, all instruments, all equipment that is needed for a safe cargo handling. Why is it not working again? No, apparently not. Let me try it this way. Yes, that's better. First word about piping. It's the easiest part, maybe. As I mentioned already in the previous session, all cargo piping should be situated above deck. Nothing under deck. And as you know already, there is no pump room. The cargo piping system should be segregated from all other piping. Sounds logic, but okay, it's stipulated again. With other piping, they mean everything which is related to inert gas or to fire line or to anything else. Any other lines on deck. Easy. Should not pass through a not cargo related space, so you cannot have cargo lines in the forepeak or in the non-gas dangerous spaces, and so neither in the accommodation, not in the machinery, because that are all declared safe spaces, as we've seen in the previous presentation. Now, for the machinery, there is one exception, and that is on board of an LNG carrier, where the boil-off is used for propulsion. There, of course, you need one line that brings the LNG boil-off, LNG vapors to the boilers. Should be on open deck, as I mentioned, should be above deck, and should be inboard of the transverse tank location. I thought I had a picture of that. No, I don't have it. What does it mean, located inboard of the transverse tank location? Well, that means that if you look to the ship from above, with a drone, for example, you have a drone above the vessel and you look downwards to the ship, that all the lines must be situated above the cargo tank spaces. Cannot go over the area where the tanks are not situated. So maybe I have to make a small drawing, but that's because that sounds quite complicated what I'm telling now. So imagine that this is here our first tank, our second tank, and our third tank, and that around that we have a vessel. I will try to do my best. Up. So that this here is our ship, something like this. Well, what it means is that all lines, all cargo lines, should be situated into this square, into this red square. Here you can have lines, cargo lines, on open deck. No problem, as much as you want, but you cannot have them here. They must be situated above the tanks on open deck. That means that here you have a corridor. Remember what we said last time about the protective location. These distances were quite high for a type 1 ship. Type 2 ship was only 76 centimeters. But of course, it would make no sense if your line is going here. Yeah, then you don't have your cargo in a protective location. So that is the reason why the lines can only extend upon the limits of the cargo tanks, here indicated by the red square. That is clear, I think. Okay. What kind of lines? This is maybe an important drawing just to indicate the different cargo lines on board of a gas tanker. They're not, it's not a large amount of lines. It's not a chemical tanker where you really have the spaghetti, but here the number of lines is quite okay still. But it's important to know what lines are situated on each tank. So the first line we find, and that is also the indicated normally in red, is the loading line. The loading line is simply a line that goes completely to the bottom of the tank, by which we will load. But that same loading line is also used as discharge line, at least part of it, because we will have here valves that will isolate the drop line. The pump, which is situated in the sump, as you remember, will pump through this here to the discharge line and discharge it that way to the manifold. The manifold is to the right on this drawing. Here at the pump, we also have a non-return valve, which is not indicated on this drawing, but we have here a non-return valve to avoid that during loading, liquid would come over the pump to the bottom. That is not allowed on board of gas tankers. We never load over the pump. We always load by the loading line. Some ships, definitely not all, because stripping is not the most important part of gas transport, but some ships have a stripping line. Then we have a vapor line, normally a little bit smaller in diameter compared to the liquid line. We have the vapor line connected at 100% height of the tank. So in fact, it's nothing else than just a hole in a tank. Vapor line. Then the largest diameter line is the ventilation line. What is the ventilation line? The ventilation line is connected to the two safety relief valves. Safety relief valves are valves that will open automatically as soon as a certain limit pressure inside the tank has been reached. They will open automatically and they will send vapor through the ventilation line to the vent riser. Completely automatic, they will open completely automatically and they will close completely automatically. You don't have to touch them, you cannot do anything about them, not even block them. That's the goal of it. In normal operation, they are always closed. If they open, that means that you as operator has done something wrong. Excuse me. In order to avoid or to allow a high rate to the vent riser, because it might be that high flow is necessary to avoid explosion of the tank, so that a huge flow of vapors need to be transported very quickly towards the vent riser. The diameter of this line is huge. You'll see it immediately. When you put your first step on board of a gas tanker, the largest diameter line is definitely the ventilation line. Then another important line, which you will not find on other ships, is the spray line. The spray line is a small diameter line, but also a liquid line. It serves to send the condensate from the cooling installation towards the tank. So you know that a cool or reliquefaction plant will take vapors from our tank here, will send it through the vapor line towards the reliquefaction plant. The reliquefaction plant will cool the vapors, will reliquefy the vapors, and this liquid, which we call the condensate, is then sent back by the spray line towards the tank. It's a closed circuit which at sea is normally running to keep the tank cooled. On the spray line, you have two connections. You have one spray header, which is nothing else than a simple small diameter line equipped with nozzles at a certain distance from each other. Or you can send this to that header, or you can send it also directly to the sump. The condensate, I mean. What is the advantage of sending it through this header? Well, then you got here a kind of spray that will further cool down the vapors on top of the liquid. We will see later when we will use this spray header, but at this moment it's just important that you know that it is there. So, and that we have two options with this condensate coming from the reliquefaction plant, or we blow it through the vapor header, or we send it simply to the sump. And then we have here three very small lines, about 1 inch diameter. These are sample tubes. These are sample tubes, and they allow you to take vapor samples at different heights in the tanks. This is especially useful when we are gas freeing or gassing up a tank. When we change the atmosphere in the tank, then we will use these tubes. So keep this drawing very good in your head, because you will need it later on. The two most important ones are, of course, the liquid line by which we load and by which we discharge, and then the vapor line. This was, of course, a drawing for only one tank. You must know that we will have that for each tank. But on board of a gas tanker, we will speak, when we are talking about lines, we will speak about systems. And for each system, we will have a complete line diagram. That means we have a complete set of lines, liquid line, vapor line, spray line, ventilation line, and so on, for each system. Let's assume that we have a ship with two line systems. This means that that ship can load two different cargoes, or maximum two different cargoes at the same time, because each system can be fully segregated from each other and allows you to carry two different cargoes. So an important thing to know when you arrive on board of a gas tanker is how many different cargo systems are here on board. It has nothing to do with the number of tanks, only to see with the set of lines. How many set of lines, how many systems are on board of this vessel? For an LNG, it doesn't matter, because LNG has only one cargo, so there will also be only one system on board. It doesn't matter. But in LPG, there might be that in tank number 1 and 3 you are loading propane, while in tank number 2 you are loading butane, for example. Well, then you need two set of lines, two line systems. That means that each system, and as in this drawing, I really simplified things. This is a ship with two tanks, as you see, but also with two systems. So this ship is able to carry two different cargoes at the same time. That means that also the manifold must be doubled. You will have a manifold 1 and you will have a manifold 2. Each manifold with a liquid line and a vapor line and a drain line or booster line, whatever. We'll come back on that later. But everything is then in double. The goal is that you can take away these spool pieces, these connections, and that you can completely segregate system 1 from system 2. This is the system with ammonia, and this will become the system with VCM, for example. While if you load only one cargo, well, then you simply reinstall these connections, and you can only connect the forward or the aft manifold, but you don't need to connect both because they are interconnected here. And that this gives you more flexibility when you have only one cargo. So this is a very important principle on board of gas tankers, the set of lines, what we call the systems. I will not go into detail on this slide, but it's only to indicate that for each system, you will need also a separate reliquefaction plant. You will need separate pumps. You will need separate booster pumps, heaters, and all equipment must be doubled if you want two systems. But a lot of these systems we haven't, a lot of these equipment we haven't seen, so I will not continue on that one. Okay, cargo piping, let's continue with that. After the systems, what is in each system more in detail? Well, after the manifold, liquid line, we have a filter. We have strainers. They protect our system from any foreign object, like there are ice, stones, and things like that that can come on board, but is then retained into these strainers. The valves we are working with are almost all butterfly valves. I think Captain De Barre spent a lot of time about valves. So we can say that on board of a gas tanker, most of the valves are butterfly. For the cargo tanks, we need at least a shut-off valve as close as possible to the tank entry. So that means that when you are on the dome, that is that part of the tank which exceeds the deck level, where you have all the line connections towards the tank. So there should be at least one shut-off valve located at the dome as close as possible to the tank. Valves may be remotely controlled from the control room. Of course, that is nowadays always the case. As you know, the regulation is always a bit behind reality. May be remotely controlled, but must always be provided with a local manual shut-off valve. That means you have two valves in series. One locally manual valve and one in series with that valve remotely operated. At the manifold, you have, as on every tanker, you have an ESD valve. That is the first valve that you will encounter when you start following the line from the manifold towards the ship. ESD valve, we will come back on the ESD system later, but most of the time that's all automatically operated depending on certain criteria conditions. I mentioned that. ESD valves at the manifold. The problem is the closing time of the ESD valves. If they close too fast, you will get broken lines and gas on deck. If they close not fast enough, yeah, what's the use of an ESD valve then? So in general, this time should be between 20 and 30 seconds for a gas tanker. Of course, nowadays we have better ESD systems, as we will see later on, where you stop first the pump and then only close the valve. This is again regulation which is behind on the real life, on the real working principles. ball valve. Oh yeah, the ball valves. Yeah, maybe that is this. You will find these ball valves. You will find on the smaller diameter lines, like for example the spray lines. Spray lines. These will be equipped with ball valves. But as soon as the diameter is above 6 inch, the diameter of the line, you will have the butterfly valves. These ones. Huh? You will become, when you sail on board of a gas tanker, you will become a specialist in the maintenance of these valves. Huh? Very important that you understand how it works, that you can replace an actuator, that you can replace the seat of this valve, and so on and so on and so on. But that you will learn all on board. Very nice to see. Cargo hoses, well, I don't want to spend too much time on that because you've seen that with Captain De Bar, I presume. But hoses should be tested, should have a certificate, should withstand 5 times the working pressure, and so on and so on. On board of a gas tanker, the hoses are mostly of this type, namely with a woven stainless steel braid around the lines in order to resist the extra pressure in the line. I don't like to use it. So if you can avoid it, don't use it because it gives you, it increases only the chance that you have leaks somewhere. So I don't like to use it. But okay, sometimes you come in a port where they're not used with the gas transport, and where you just have to connect a line which is on a bulk terminal, something like that, that goes into tanks further away. Well, then you have to connect with hoses, and there's no other option at that time. But I prefer not to use it. Cargoes handling, how you must handle them down by using the crane so that they are not bended downwards, but always a bit upwards, and that the spreader is used, that they are well sitting under the right angle and not in between the ship and the bird, and so on and so on. That's not so important for us on board of a gas tanker. As I mentioned, we prefer to avoid it, but it can be used, and then you will have it on board somewhere in the locker, but we're not happy to use it. Much more important is the pressure relief system. Pressure relief system or ventilation system. First, I want to repeat that our tank is always filled with only the gas. Here I mean that the cat has a cough. Here I mean that in the tank, there's only liquid of our cargo and vapors of our cargo. There's nothing else inside. No IG, no nitrogen, and definitely no oxygen. So completely filled with cargo. Keep that in mind. That is the only tanker where it is like that. Yes, it's a gas tanker. Because then we are far above the upper explosive limit, and there is no danger to have any flammable mixture inside the tank. But of course, since we have so, you can imagine a situation where if we don't do anything to this tank, that the boil off will continue, that we will create more and more vapors thanks to heat that is penetrating through the insulation. More and more liquid is evaporated and the pressure above the liquid increases. If we don't do anything, suppose that you don't start a cooling liquefaction plant on board of a fully ref ship, yeah, at a certain moment you will come to pressures where the tank is not capable of withstanding this pressure, and that you'll have a tank explosion. Of course, that we want to avoid. So imagine that you were in the control room, but you fell asleep. Yeah, at a certain moment, you will have an alarm on high pressure in the tank. If you continue sleeping, then you will have a second alarm. But at that moment, you will also have shutdown of pumps and other equipment except the reliquefaction plant. But if your reliquefaction plant is not running, the pressure will still increase. And at a certain moment, far before the rupture of the tank, you need some extra safety. Well, this extra safety was this safety relief system. Safety relief system that will open automatically, even while you are sleeping, will open automatically and will release vapor pressures towards the atmosphere. You know that's not allowed of venting into the atmosphere, but of course, when it is for your safety, then and only then it is allowed. This system is completely automatically and should be equipped with two what we call safety relief valves. At least two for each tank. They must open at the MAVs, and the MAVs is the maximum allowable relief valve setting, which is below the maximum design pressure of the tank, of course, which is situated for most of the ships around LPG ships around 440 millibars, LNG around 24 kilopascal. More or less for each ship it's different, but then at least you have an idea at which pressure this opens. These are here, I hope you see my cursor. These are here the safety relief valves. So this is one and this is one. Most of the time, the ventilation line, because this is the ventilation line, you see the huge diameter of this line, and this is what is coming from safety relief valve number 1, safety relief valve number 2, comes together in this big line going to the vent riser. Here you see the whistle. Whistle is the measuring instrument, the manual measuring instrument for taking a level measurement of the liquid inside the tank. Now that we have a picture of it, I can show it to you. But okay, we were concentrating on the safety relief valves. Open automatically, close automatically. You will see there is nothing that you can change, nothing that you can open or close. It's completely a closed system. It goes automatically on and off. Normally, and this is normally, they are not painted because they are completely out of stainless steel. So there's no need to paint it. Like on this ship, the previous one, they were painted white. That makes no sense. It's a waste of energy, time, and paint. What happens is that, and here you see also the direct connection to the vent riser. Yeah. So you see it's only very short distance of ventilation line. So the safety relief valves open, huge amounts of vapors go through this line and directly to the vent riser. Vent riser, which is a minimal 6 meter height, but which is completely opened at the top. Now imagine that we are sailing in a Persian Gulf with temperature around 40 degrees, and that means the sun is shining the whole day on these lines. They can become really hot. We measure temperature up to 70 degrees of the steel, and also the deck steel. Then the paint is coming out of the deck because of the heat of the deck plate. But imagine that this steel is also warming up, and that at a certain moment this valve opens and you send vapors of -40 through this line. The temperature difference can be more than 100 degrees. What will happen? Well, this steel is fragile, it's brittle, and it will burst. And that is why we have these small rings here, or looks like rings. It are no rings. These are expansion bellows. Expansion bellows that must withstand the shrink or the expansion, depending on the temperature, but most of the time it's a shrinkage, of course. They must withstand the shrinkage of the material due to the sudden temperature difference. So each safety valve is equipped with these expansion bellows. This is This is my first vessel ever where I boarded. This was the view which I had in my cabin when I was apprentice. You see that we are here with the gas tanker at the bulk terminal. You see here the bulk crane and the transport band for the coal or the iron ore. I don't know what it is. But here they had at least one jigsaw to connect. This was a beautiful vessel. I stayed on board 7 months, and we did a beautiful voyage. It was tramping, of course. We went to Australia, Korea, and so on and so on. We did the Pacific, we did the Atlantic. Beautiful things. But all to the past. What I wanted to say is that here, I would try to explain a little bit based on this picture. This here, you see that this is higher compared to the deck. This is the deck level, okay? This is a bit higher. This is the tank dome. This is the area where all lines connected to the tank will come to the deck. Here you see our two safety valves. Yes, these are the two safety valves connected to the aft riser. Here you have a forward riser. So this was a ship with 3 tanks, one forward. Then you have the compressor room, motor room, and here on top this block was the control room. Then you have here tank number 2 and the manifolds. So here it's a bit spaghetti, I must admit. And then here completely aft you have tank number 3. Notice that here you have no lines. As I mentioned, the tanks are coming more or less till that's more or less the width of the tanks. Here you have always a free catwalk, a free walk, let's say, because catwalk is here. You have a free walk here on both sides of the vessels because of this protective location. Yeah? You see also that the line is frozen, is white here. This because the line is frozen, the line is white. Normally the line is not, is simply gray or iron, stainless steel. But here is frozen and we are loading. We are loading cold cargo, which is normal on board of a gas tanker. And you see that this here is the loading line. Jups goes to the tank loading line and then completely to the bottom. And here, this valve is what we call this shut-off valve. This is a valve as close as possible to the tank entry, and this is really close because there's only one elbow of 90 degrees and then you are inside the tank. So this is the manual shut-off valve, and you will have here somewhere the automatic one. Mention also, although it is not so good visible, but this line is the vapor line, and you can see it because that line is isolated. There is isolation around that line, and that is why you can see that it's the vapor line. How can I see that we are loading? Well, because here are the pumps of tank number 2. The pumps are always at the back of the tank, so aft. That is the reason why you always need a positive trim. Never on board of this kind of vessels a negative trim. Always positive. That is because the pumps are situated aft and the sump is situated aft and so on and so on. And you have here, you see that compared to the deck level again, the pumps are situated on an extension which is a bit above deck level. This is what we call the pump dome. So it's another penetration of the tank through the deck level. It's another dome, namely the pump dome. So we have for each tank, we have 2 domes, namely the tank dome, where all the lines will pass, and a second, a smaller one, where the 2 pumps, one is here behind the vent riser. So another one where the 2 pumps are situated. And I see that we are loading since the canvas is still around the motors of the pump. So the green canvas is still around the motor of the pump. So if the canvas is around it, that means that we're not using it. Okay, that for this indication. Right. Okay, let's go back to where we were situated, namely the safety relief valve. or the safety valves called. Also, there are different names for this kind of valve, but it's a very, very important one. Okay. You have to see that the safety valves are part of the pressure relief system of the ventilation system. It's a whole system, since there are not only these relief valves, but on each line we have also relief valves. Therefore, I need again a small drawing. If we take a line, why is it not doing anything? If we take a liquid line, for example, like this, and we have two valves in it, one here and one valve there. Okay, so we have a piece of line, liquid line, and imagine that we stop loading now. Loading is stopped, and we close these two valves, because here is the tank and here was the manifold. So we close this valve and we close that valve after the loading. What will happen in this line? Well, if you didn't drain the line, that means that this piece of line is still filled with liquid, completely filled with liquid. That thanks to heat from outside, this liquid will start to boil, will evaporate partly, and the pressure in the line will increase and increase and further increase. And finally, one of the valves will burst or leak, or your line will burst. And that is, of course, a situation we want to avoid. So the first rule in gas handling is never imprison cargo. Here you really block a certain amount of cargo. It cannot go either way. What you need to do is you need to leave the valve towards the tank open, so that this liquid can drain slowly to the tank. And if it cannot drain to the tank, it will evaporate, but the vapors will go to the tank. Finally, everything will come into the tank. Yeah. But just make sure that you don't close too many valves. That's important on board of a gas tank. You can make the error of closing too many valves. But in order to avoid this, and this is what we call a liquid trap. Liquid trap is when you close both valves and you imprison liquid in between these two valves. Then we speak about liquid trap. To avoid liquid trap, we will install here a safety relief valve, spring operated. That means at a certain pressure of, for example, most of the time it's around 16 bar. When the pressure inside that liquid line achieves 16 bar, that pressure relief valve will open. It's a small relief valve, will open, and it will bring your liquid towards the vent riser. Sorry, that's a bit too fast. Where is it again? I know. Oh, this is my line where I have a liquid trap. This is my spring-loaded relief valve that will go to or a vaporized tank. That means that is a tank of special steel that resists the cold temperatures of the liquid. Therein, the liquid will evaporate and the vapors will go through the vaporizer. Most of the ships, this vaporizer tank is incorporated inside the bottom of the vent mast. That means that the bottom of the vent mast is made of special steel resistant to the very low temperature of the cargo, so that the liquid can evaporate it and can evaporate at the bottom of the vent mast. The spring-loaded relief valve. That means that we have this kind of valves on each piece of line where you can create a liquid trap. So in total, you will have something of 60 of these valves. On a normal gas tank, you will have about 60 or even more of these valves. Because each piece of line where you can create a liquid trap, that's quite a lot. Safety valve should be fit for cold service. They may not block when cold liquid comes through it. The height of the vent should not be less than 6 meters above the deck and 25 meters from the nearest air intake. Yeah, okay. Should be much more, but that's practically not possible. So they said it's 25, but please make sure that when you expect vapors coming out of the vent mast, that you take the relative wind from at least 90 degrees from the bow, at least. Separate pressure relief system from separate cargoes. That means this is the story of the systems, which I try to explain. Vent mast should be fitted with means of liquid draining, a special steel, as I mentioned, and flame screens on the vent outlets. This is what we call the spring-loaded relief valves, which you will find on each piece of line where we can possibly create a liquid trap. So the principle of working operating principle is very easy. You have here a seat that is pushed towards the closer of the valve here with a spring. The tension of the spring you can regulate with this button here should be set to a certain opening pressure. And then normally, theoretically, it will open at a certain well-defined pressure. If the pressure in your line exceeds the pressure of the spring, then the valve will open and then liquid will be released towards the ventrizer. Quite easy. Quite easy, but not so accurate. So imagine that you want them to open at 16 bars, well, she will maybe open already at 15 bars or maybe only at 17. Very difficult to regulate exactly. That is a bit of a problem with these valves, but okay. All right. You remember that we have also pressure relief valves on the tanks. But when I say that these relief valves, spring-operated relief valves, are not so accurate, we need extremely accurate relief valves for the tanks. Because as I mentioned before, for a fully ref tank, this valve must open at a pressure situated around 440 millibar. And then 1 bar more or less, yeah, that makes a huge difference, then your tank will have exploded. So the safety relief valves on the tanks are much more accurate than the ones on the lines. And I will try to explain you why that is so. The reason is because the operating principle is different. They will use a pilot valve. So the operating principle of the pressure relief valves from a tank is based on the working of the pilot valve. What is a pilot valve? That is a small valve that will guide the main valve. This is a drawing of the safety relief valve from a tank, where we have here at the bottom the tank. With the tank pressure, of course, we are here in the ullage, so everything in blue is the vapors, are the cargo vapors. Cargo vapors, which through this line sends the same pressure over this whole system. So everywhere where you see blue is the same pressure, the same tank pressure. On condition that it does not exceed the opening pressure of the pilot valve, of course. So this here is the pilot valve. this small thing here with the seat here. So in this moment it's closed. And this here is my main valve. This is the opening towards the vent riser. So in this case, my seat here is also closed. Main valve is closed and the pilot valve is closed. This is in fact a kind of membrane diaphragm that is operated by this pilot valve and is in communication. So what we have now in a closed condition, this is position closed, number one, closed position, we have that the tank pressure is going to both sides of this diaphragm. And that means that here is another smaller spring, more accurate spring that keeps the pilot valve closed, because above and under the diaphragm here is the same pressure, namely the tank pressure. Here for this diaphragm that operates the main valve, we have only pressure above the diaphragm, so the diaphragm is pushed on its seat and closed. That's the normal condition. And again, you as operator should make sure that this condition is maintained. If it's not maintained, that means that you made a mistake. This is completely different compared to what you learned from Captain De Bare when he was speaking about PV valves. PV valves, they open and close during normal cargo operations. This is a safety valve for your safety, not for your operation. You should maintain the pressure inside the tank with your reliquefaction plants, not with this valve. It is not allowed to open this valve for just operational purposes. You will not be able to open it because it's fully automatic. Okay, let's assume that the pressure in the tank here exceeds the opening pressure of the valve. So what will happen? We'll have too much pressure here in this area below the diaphragm, and that will open the pilot valve. As soon as the pilot valve is open, small amounts of vapor will go through this way and through this mount to the open deck, will evacuate. That means that in these green lines and in this compartment here, we will have what we call an intermediate pressure. An intermediate pressure which is below the tank pressure. Okay, thus, on one hand, we have here an intermediate pressure. On the other hand, we have here a tank pressure. So the pressure on the tank exceeds the pressure on the membrane, and also the membrane will open as soon as this pressure has fallen sufficiently. And then in my third position, the membrane, the main membrane, will move upwards, open the valve, and large amounts of gas, vapor, can escape towards the vent riser. You will see here that we have a narrow diameter because from the tank pressure, this pressure will drop, and at a certain moment, this spring here will have sufficient power to close the pilot valve back again, so that this pressure in the line here, but especially in the compartment here above the membrane, can increase again until it is at the same pressure of the tank, and then the valve will close again. But as I mentioned before, this will happen completely automatically. Should be avoided. Because once it's opened, it takes some time before it closes again. Oh, you really want that it's closing, No, it does not close. Your pressure should decrease with at least 8 up to 10 millibar before it closes again. And that takes a while, I can assure you. I can assure you. Okay, so I mentioned that according to the IGC code, all tanks must have at least 2 of these safety valves. But type C tanks and the hold spaces, they may be equipped with bursting discs. What a bursting disc? Bursting disc is nothing else than a simple circular plate. Circular plate of a well-defined thickness and well-defined material that you use as safety valve. That means at a certain pressure, when you install this circular plate in your line, at a certain pressure, it will burst. It will not resist the pressure anymore. And then it's broken and gas can escape towards the vent riser. Of course, at that moment, you will lose all your vapor pressure, and you must replace this disc. You can only use it once. It's a bursting disc. It will break when the pressure is too high. This is used or may be used as well for Type C tanks as for the hold spaces. On Type C tanks, it's maybe possible, but for hold spaces, they will also install simply a safety relief valve, as explained before. All pipelines must be equipped with safety relief valves. I explained that. Yes, some relief valves have different settings. Maybe it's too early to explain that. I will skip it at the moment. I will come back on that later. That is our protection for excessive pressure in lines or tanks. It's a pressure relief system or ventilation system. Very important. Remember that Chief Mate is only thinking about the pressure in his tank on board of a gas tank. Do we need a vacuum protection? At first view, we should say no. No, there is no reason why we should protect for vacuum. Since our gas is boiling and since our gas is always sending or evaporating vapor, so increasing the pressure instead of decreasing the pressure. However, there are a few situations where a negative pressure might be possible. For example, if you forget to stop your reliquefaction plants, if you cool too much, if you cool below the boiling point. This is definitely something you must not do. But let's assume that you continue cooling down. Well, at a certain moment, you will get a negative pressure in your tanks. That is absolutely not admissible. You should avoid that. You must avoid that. But of course, we are on board of a gas tanker, so there is a protection on that. As soon as your tank pressure becomes below a set pressure, and that is situated between +7 and +10 millibars, something like that, all your compressors, all your reliquefaction units are stopped automatically. And you will not be able to restart it. So even when you fall again asleep, your reliquefaction plants will be stopped automatically. That's the first vacuum protection. When is there another possibility of negative pressure? That is when you are discharging at a very, very high rate. Then it is possible that you are discharging so fast that the evaporation is not sufficient to maintain a positive pressure. So same thing happens even when you are sleeping. If your pressure achieves 7 to 10 millibars and your pumps are running, they will be stopped automatically, just to avoid a negative pressure inside the tanks. If they are stopped and your pressure is still 7 millibars, from then on, your pressure will start to increase again. There is only one situation where you should interfere yourself, and that is namely when you receive from shore a cargo which is too cold or a cargo which is below the boiling point. I had it once, and then you should quickly start creating vapors yourself. I will come back on that later. So the vacuum protection is most of the time automatically, and it's an electronical protection that stops all instruments as soon as you reach a certain set pressure, most of the time situated between 7 and 10 millibars. All right. As the last part of this video, I will treat the different cargo pumps. There are two important types of cargo pumps on board of a gas tanker, namely the deep well and the submerged pumps. Deep well is more for the smaller vessels, small or mid-size vessels, being the LPGs. On the larger LPGs and on all the LNGs, we will have submerged vessels. Booster pumps is an additional pump, and inductor, Captain De Baere explained you what an inductor is. An automatic control and protection of the pumps and the ice prevention. That are the items that we will discuss in this part of the course. Theory about pumps, you had a lot from Captain De Baere, but our pumps will be centrifugal pumps, so kinetic centrifugal pumps are the pumps that we will use on board of gas tankers. Discharging of your cargo on board of a gas carrier can be done by the following methods. By a centrifugal pump, which is situated inside the tank, inside the sump of the tank. By a combination of a centrifugal pump inside the tank, the sump, and a booster pump on deck. A booster pump is a pump which is identical to the cargo pump inside the tank, but it is only a pump that we will use to increase the discharge pressure. So that means we will put a booster pump in series with the cargo pump. For example, when our tank is, or when the tank from shore is situated up on a hill, or far away, there's a very long line 3 kilometers away, and the tank is 3 kilometers away. So then you need a lot of pressure to achieve that tank. Or when there is too much back pressure in the tank, then also you need a booster pump. You have learned with Captain De Baere that two pumps in series will increase the discharge pressure, not the flow rate. And that is what we will use when we install or when we use the booster pump. So booster pump, just see it as a traditional cargo pump. The only difference is that it is situated on deck and that you can use it whenever a higher discharge pressure is needed. You can discharge with an inductor. You can discharge Type C tanks by increasing the pressure in the tank and then just open the valve. That's also a way of discharging. Or you can increase the pressure inside Type C tank, open the valve so that the liquid achieves the deck level, and at deck level use the booster pump. Okay, first pump we'll discuss is the deep well pump. Deep well pump is a pump where the centrifugal pump is situated inside the sump and is constructed of 3 stages. So in fact, you have 3 propellers, 1, 2, 3. 3 stages, one after the other, just in order to have sufficient pressure to pump the liquid upwards to deck level and then ashore. This pump is activated by the shaft, which is connected to this electric motor. This electric motor is situated on deck. Around the shaft, we have the discharge line. So that means that the shaft is lubricated and cooled with our cargo. It is therefore of utmost importance that you always have a flow. This pump cannot run without flow, because then it's not lubricated and it's not cooled. This is inside the sump. So here, this square here is the sump. The size of the sump on a mid-sized vessel is something like 1 or 2 cubic meters, not more than that. As small as possible, of course. Here you have the different stages of the pump connected to the axe, which is also the discharge line. This is the deck motor, the motor which is connected to the axe here, situated on deck. And here you see in dry dock, we took out the pump, and then you have an idea of the length of the axe, which is more or less the height of the substructure. You can imagine that there are a lot of forces on this axe. So this axe is limited in length, and that is the reason why I said this kind of pumps, this kind of deep well pumps, are used on the smaller or mid-size gas carriers. For the larger gas carriers, where the height of the tanks is even larger than this one, you will have too much vibration on the axe, too much vibration and forces that will destruct the axe. And therefore, this principle cannot be used anymore, and you should go to submerged pumps. The advantage of this pump is, of course, that you have the motor here, the motor on deck. So if there is something wrong with the motor, you don't need to gas free your tank to have access to the motor. You can replace the motor while the tank is still under gas. That's a huge advantage. Also the costs, of course. The cost to produce such a motor is maybe half or 1/3 of the cost of a submersible motor, which should be protected for liquid. This one is also protected for liquid, but not for submersion. Okay, the double mechanical seal. So the problem with this pump is the penetration of the axe through the deck level. Yeah? This must be liquid tight, of course. It is not allowed that gas escaping from the tanks through this hole where the axe pass. So we need a kind of gas tight closure around the axe. And this is done by the use of oil. We have a double mechanical seal, one here and one there. And inside this small chamber here in red, we have oil, light loop oil, which is used to keep an overpressure, namely the pressure of the tank, inside this compartment. So with this line, the tank pressure is set on top of this piston, and this piston pushes on this loop oil reservoir that sends additional oil towards the compartment. And that makes sure that this area is completely gas tight related to your tank pressure. What will happen if one of both mechanical seals starts leaking? Well, oil will escape since we have an overpressure here in this compartment. The first possibility is that the upper one is leaking. Then you will have oil that is escaping here towards the deck level. That's completely safe. There's no problem. You will see that the height of the piston here has decreased because the remaining oil here, the spare oil here has decreased since you are losing oil, and you will see the oil appearing on deck. When you see the oil appearing on deck near the motor, you know that our upper mechanical seal is leaking. Very easy. You take away this pressure, the lower mechanical seal will make everything gas tight, and you can replace the upper one. On the other hand, when you see that this piston is going down, that the liquid in the reservoir is decreasing and decreasing, and there is no oil on deck, then you know that it's the lower seal which is not gas tight anymore, because the oil is then flowing into the tank. Only small quantities, of course, but you know that then your lowest seal is broken. That seal you can only replace when you made the tank gas free. So that is the thing for or dry dock or whenever you change cargo if you're on board of an LPG. But on an LNG it's more difficult, but they don't have this kind of pumps, of course. So that is the way how we assure that this pump X can pass through the deck line without gases escaping. That's the double mechanical seal with oil flush. It is the task of the apprentice to keep sufficient oil here in the oil reservoir and to verify during operation whether there is no oil and whether this piston remains at more or less the same position, because otherwise you have a leaking seal. Theory of the deep well pumps. Captain De Barre has spent hours and hours on this, so I don't need to tell you a lot about that. Although there's one thing I want to emphasize, that's the net positive suction head. We have a cargo which is carried at its boiling point, okay? So as soon as you create above that cargo a negative pressure, you will have evaporation, you will have vapor, and you will have cavitation in your pump. So you cannot create any under pressure at the suction side. And that is the reason, of course, why your pump is situated completely at the bottom of your tank and even in the sump, even lower than the bottom of your tank. And it always helps to get a little overpressure inside the tank. I mean, overpressure from your vapors that will assist you when you are pumping. But net positive suction head is a problem on board of gas tank. So it's very difficult to do the stripping on board of a gas tanker. Now, most of the time you don't need to do, especially when you don't change your cargo. You don't have to change from cargo. You can keep the same liquid on board, and there is no problem if you leave the sump full of liquid. This 2-3 cubic meters, nobody will care about it. That is normal that you keep that on board just to keep, in order to keep your tanks cold to the next loading port. So there's no need for stripping neither. There is, of course, a problem when you start, when you need to change cargo. Then you will do your best to do the stripping as well as possible, but you will not succeed to discharge all the cargo. The cargo remaining, the liquid remaining, must then be evaporated later on in order to empty also the sump. This is what I just tried to explain. Deep well pumps. Oh yeah, remember also that the specific gravity of gases can change quite importantly. So that you have gases with a specific gravity of 0.5, but the heaviest gas, as I discussed in the first chapter, is 0.97, which is quite heavy. And of course, that will have an influence on your flow rate, and it will have an influence on your back pressure that you can give. VCM is a very heavy gas, the heaviest gas that you can transport. All right, second type of pumps are the submerged pumps. And submerged pumps, as the word it says, there the pump and the electric motor are submerged. You have not an axe, but only an electrical cable that comes down, and around that you have the discharge line. The motor is completely at the bottom of your tank. There is not too much to see on deck. So you don't have the problem of mechanical seals and so on and so on. There's an advantage with this one. The only disadvantage is that when there's a problem with the electric motor, you cannot discharge anymore. You must use the other one at the other side, your port side one or starboard side one. If that one is not working neither, you must install the emergency pump as we have discussed last time. And to repair this tank, you must gas free your tank. Otherwise, you cannot repair the pump. This is the system which you will find on LNG carriers and on many large LPG carriers. Booster pumps. As I mentioned already, it is mainly on LPG carriers. I've not seen that on LNG carriers, and I don't think it exists for LNG carriers. I don't see the need for it neither. So only on board of LPG carriers. They are mounted then on deck. So in series with the cargo pump to increase the discharge pressure. Okay, for that I need to make an additional drawing, I think. Yeah, this is the presentation. So here you have the two tanks, and they are. It is possible to insert this third pump, this third pump in series that will increase the discharge pressure. The capacity of this booster pump is exactly the same as the one of one cargo pump. So it makes no sense to start here both cargo pumps at the same time to feed only this one pump. Since they have the same characteristics, the same capacity, you start one cargo pump, you build up a pressure here. Once you have sufficient pressure here at the suction of this pump, then only you start a booster pump and you discharge at higher pressure. So as you know that when you put two pumps in series, you will increase the back pressure, but you won't increase the but that is not our goal to increase the flow. The goal is to increase the back pressure. I lost my screen. Okay. It is now time maybe to explain when we will use the booster. So let's assume that we have here a type A tank, and that we have here a type C tank. And that this is our ship, this is the ship, and that this here is the shore. So we must discharge from a type A tank towards a type C tank. Yeah? Okay, I will draw the discharge line to make sure that we're doing things correctly. Yopla. Voilà, like that. What are the conditions inside the type A tank? Let's assume that we have cargo, or whatever, it doesn't matter, NH3, easy, ammonia. Okay, what are the conditions of the ammonia in the type A tank? Type A tank is a fully refrigerated tank that will not resist to pressure. So that means fully refrigerated, the temperature in this tank will be something around minus 33 is the boiling point. So let's say minus 32.5 degrees Celsius is the temperature in that tank. Right? What is the pressure in that tank? Well, the goal is that there is a slight overpressure, and with minus 32.5, I estimate it will be something like 15 millibars, not more than that. That is a condition in the type A tank on board of the vessel. Here we have a type C tank where we should discharge this ammonia. What is the condition of the little amount of ammonia which is already in this tank? It's a type C tank. That means it's a pressurized tank. So the temperature inside this tank that is ambient. I'm looking outside. Today it is 10 degrees. Okay. Voilà. 10 degrees inside the tank. What is the pressure inside this tank? Well, that is depending, of course, on this temperature. And you can look up the saturated vapor pressure of ammonia for 10 degrees. I don't know that by heart. I will say something like, okay, I don't know, 6 bars. Oh, sorry, P equals 6 bars. Normally, if you discharge this here towards that tank, you need your pump, which is this deep well pump, must overwin the height, must overwin the resistance of this line, must overwin the difference in height between the two tanks, and must overwin this pressure. If we add all these resistance and all these pressures, it might be that we exceed the capacity of the cargo pump. Especially when the temperature is higher in summer, or when you need to discharge in Mediterranean, for example, and instead of 10 degrees, it's 20 or 25 or 30 degrees, this pressure will go up to 10, 12, 13 bars. Then one cargo pump is not sufficient. So at that moment, you must give an aid, you must help a little bit with this, what we have seen, booster pump. The booster pump, you will increase the pressure of the cargo on deck level. So the cargo pump pumps the liquid up towards deck level. At deck level, the booster pump increases the pressure to overwin this back pressure inside the Type C tank. But there's a second problem. We discharge liquid at a temperature of minus 32.5 degrees. The steel from this Type C tank is not resistant to that very low temperature. They are used to ambient temperature. Okay, they can accept some negative temperature, maybe minus 10 or so, but not lower than that. At this moment, it's 10 degrees. So if we add minus 32.5 to these 10 degrees, we will have a huge flash off also. So the shore will set criteria according to the temperature. They will say, listen, you can discharge at a maximum temperature, at a minimum temperature, minimum temperature of, for example, let's say 0 degrees Celsius. So you not only need to increase the pressure, you also need to increase the temperature. Oh, sorry, this is wrong. You also need to increase the temperature, and that is done with what we call the heater. The heater will warm up your cargo. Watch out. The heater will warm up the cargo, but not evaporate the cargo. We will still discharge liquid. Why is the liquid liquid not evaporating because it is under such a high pressure. That is the reason why it is very important that we first build up the pressure with the booster pump, and only after that we will increase the temperature with the heater. If you reverse these two elements, you risk of evaporation and your booster pump will cavitate. So it is always in this order. First the booster pump, then the heater, and then you can go to the Type C cargo tank. This is an important application of gas tanker handling. Of course, when you need to load from a Type C tank into a Type A tank, other problems will arise. Type C tanks, they don't need to start a pump. They just need to open their valve, and by this pressure only, the liquid will arrive on board. But the liquid will arrive at a temperature of 10 degrees and not of minus 32.5. So the pressure in this Type A tank will increase very rapidly. And very rapidly, your safety valves will open. You are not able to control your pressure. That means that the rate at which you load here must be adapted to the capacity of your reliquefaction plant. Your reliquefaction plant must cool down the cargo you receive to minus 32.5. So in this case, that's 42 degrees of temperature difference that you need to overwin with your reliquefaction plant. I think you will stay more than a week alongside. I was lucky because if you have this, if you have come with a mid-sized gas tanker in the Mediterranean region, there are a lot of these Type C tanks, simply because it's quite warm there and they don't want this continuous cooling. So that's why there's the reason why they prefer these Type C tanks. Okay, pressure is then somewhat higher of 15 bars, but that's easy to discharge. But that's not so good for you, of course, because you need to cool down. And that extends your stay in port. Depending on the port, it's maybe one of the occasions you can go ashore, who knows. Okay, that about gas handling. Booster pumps. Automatic control of the pumps. We were talking about the pumps, you remember. Automatic control of the pumps. There are a few alarms on which your pump will trip to protect your pump. But this is completely automatic. Yeah. First one, the differential pressure. There must be a substantial pressure difference between the suction pressure and the discharge pressure. Because if that is not present, if that difference is not present, that means you will have no flow. You're not pumping. And then, as I mentioned, your axe is not lubricated and not cooled, and then the pump is stopped automatically. High amperage, your pump will stop automatically. Float gauges, if in one of the tanks you got a very high level alarm. If you got a very high level alarm, all pumps are stopped automatically. There is first a high level alarm that will wake up the operator. If he doesn't wake up and he stays asleep, then you got the very high level alarm, and then the pumps are stopped automatically. You have flow switches. If there is no flow anymore and a pump is running, the pump will be stopped automatically. Pumps will be stopped automatically by the ESD system, and pumps will be stopped automatically whenever a low tank pressure alarm happens. As I mentioned, situated between 7 and 10 millibars. An additional problem with the deep well pumps is that there is a risk, and especially when you are preparing the tanks with the new cargo, there is a risk of icing. that is humidity that is contained in the atmosphere of the tank, that when you start cooling down the tank, this humidity condensates and freezes on the bearings of the axe. If that is the case, then you will not be able to start a pump because the pump will be blocked, the axe is blocked thanks to this ice. So therefore, most of the pumps are equipped with anti-freezing points where you can inject a kind of anti-freezing to defreeze these bearings. But of course, when you inject these antifreeze, you are polluting your cargo. So this is really a last step solution. You must try to avoid this freezing of the axe. How can you avoid it? By manually rotating the axe when you are cooling down your tank. At the moment that you're cooling down your tank, then this can happen, this ice accumulation. But if you manually rotate, like let's say each half hour, manually rotate your shaft, then that icing will not happen. And that is, of course, a nice task for the apprentice. Again, but you should avoid to inject this freezing, this antifreeze, because it's only contamination of your cargo. It are only small amounts, but if they find any traces of your antifreeze into the cargo, you will pay for it, sure. Try to avoid it. Finally, we got some eductors that are placed inside the tanks as an emergency pump. In case both of your pumps are out of use, you can use an eductor to discharge the cargo to or transfer the cargo to another tank with driving fluid from the pump of another tank. Eductors are also installed in the sumps of the hold spaces to evacuate any liquid present there. That can be, of course, condensation, that can be seawater, but it can also be cargo. So this is the idea of having an eductor as an emergency pump into a cargo tank. You use the propeller pump, the driving fluid from another tank. You send that to the eductor in the damaged tank, and then what is coming out, you send back to that tank where you are pumping. And from times to times, you discharge ashore, of course, to avoid here an overflow. That's his logic, I presume. This is the presentation of the eductor into the hold space system. So depending on what kind of liquid you have in the sump here, you must make the connection here above. So let's assume that you have condensation here. So that means that you have only a small amount of liquid. You should connect this with, for example, the fire line. Connection is made with a fire line and you just pump it overboard, no problem. Same thing when you have here seawater inside, that means that your inner hull has a crack somewhere, then also you connect it to the fire line. But when you have cargo inside, you must connect this to the cargo system and you must send driving fluid, you must send cargo as driving fluid towards this eductor. So the connection here is different depending on the liquid found here at the bottom. How can you find out which liquid is inside the hold spaces? That is based, of course, on the alarms you got. If you got high pressure in the hold spaces, then you know that it's cargo because that will evaporate. If you got gas detection alarm, then also that is cargo inside the hold space. But if there is no gas detection alarm, no increase of pressure, no decrease of temperature, then it must be water. And then you can connect it safely to the main fire pump. Good. That was it for this session. I thank you very much, and I hope to see you soon in one of the following presentations.